Online students, is my voice is loud and clear? Everyone, could you please confirm? Yes or no? Yeah. So, can we start the session? Yeah. Yeah, sure. Hey, could you check once? I have already uploaded. Anwar, I already uploaded. Could you check once? Okay. Done, guys. So, in the last class, we are discussing about the different types of this one. Okay. Now that is train test split. We have discussed about train test split, where we are going to divide the data into two parts. And along with the two parts, the train data is around 80%, test data is 20%. So 20% of the data means 0.2 into the total number of records, and we are going to just apply the round figure. Okay, if the number of records are some kind of like 121 or to 122 or something number into just 0.8, you are going to multiply into the 0.8. First, I have told you what is train test split, why we have to do the train test split, reason behind the train test split. Okay. Second, I also have told you what about the bias and variance. If you remember in the last class, our last topic is bias variance trade-off. And this is one of the most important interview question and in the real life, the most commonly problem. So this is one of the most favorite interview question for everyone. So bias means nothing but, okay, bias means nothing but, uh, yeah, Gautami. First, 1 minute, guys. Yeah, before starting the class, okay, before starting the class, just I want to confirm you guys, okay, whoever has attended, whoever attended Saturday ML class, there we have covered the nonlinear regression. What is nonlinear regression models? Nonlinear regression models, particularly their equations, how the equations are derived, how they are derived. This is first one we have discussed, where we have derived for the degree of 2, we have derived, degree of 3 we have derived, right? We have derived for the different one. Second, we also have covered in the Saturday's ML class train test split, the reason of train test split and how much percentage of data has to be splitted, whether randomly or sequential order. For random data, randomly we have to split. For sequential order, sequentially we have to split, and reason behind this, why. This is the interview question, why, reason behind this. And third important point, okay, yes, that is nonlinear regression is nothing but polynomial models. And third one, we have also discussed bias variance trade-off, which is called as underfitting and overfitting. So we also have discussed here bias variance trade-off, which is called as underfitting and overfitting problem. What is the overfitting problem, right? So these are the things which we have covered in the Saturday's class, and we have to discuss only one more topic called as regularization. If you complete this topic, that is how to reduce that overfitting problem in the regression projects. Regularization is nothing but reducing the overfitting problem, which we are going to cover in the today's class. This is the only topic which was pending in the entire regression. So as I've told you in the Saturday's class, as this is pending for us, instead of continuing on the next Saturday, if I continue on the next Saturday, again, I have to explain for you so many things and the sequence will be missed. So that is the reason I told that today we'll complete this balance, what are the pending is there, so that the entire regression will be completed. Regression related to ML will be completed. Regression theory part will be completed. Theory will be completed. And on Saturday, we can do the project. Next Saturday, what are the upcoming Saturday? Upcoming Saturday, we can do project on this. With that, the entire regression also will be completed. Practical is nothing but project. So here we are going to do the practical approach by using one project. Okay. So by taking two projects, one is for simple regression, one project, and for multiple regression, one project. So we are going to cover the two projects, two end-to-end projects, where by implementing all kinds of algorithm. How many algorithms we have covered in the theory? Every algorithm practical we are going to cover on the Saturday. Since this part is slightly pending, and if I continue to the next week, again it will go, practical will go to the again next week, again it will be too lengthy. So actually regression has to be completed in the last week itself, I mean last Sunday itself. But due to that, as I've told you, today I'm going to take the ML class. And after the ML class, I'm going to share you the recording also. Only for today only, guys. The Saturday's class section is only for today. Whenever something like any topic is extended or pending or slightly, which cannot be given so much of time, in that case only I will take the extra class like that. Otherwise, regular class, as we know, our regular class will be going on. So today I'm going to complete this regression and I will try to cover the entire regression theoretical part. There will be no balance, and along with the interview questions of the regression project. What would be the general interview questions within the regression project? And then we are going to see the finally the practical part, right? So here coming to the problem, the bias variance trade-off. Okay, this is first point. Second, today's class, what are the today's class? Some students are unable to attend. Okay, in the multiple batches, some students are unable to attend. So today's class recording, what are the recording is there? Recording will be uploaded in classroom, will be uploaded in classroom, in your Google Classroom. In Google Classroom by tomorrow 12 or 11, by tomorrow by before 11:30 a.m. So I will upload that one. Once I receive the recording tomorrow before 11:30 a.m., I will upload the recording of today's class. Whoever are missing, you can go through this. As the same thing I have told in the Saturday. Some students has missed, I think, on the Saturday. Okay, could you please check that once? And second, coming to the notes. This is about the recording, and coming to the notes, the entire notes is already uploaded in Google Drive. Check once your Google Drive. If it is not still uploaded for you or anything problem is there, miss, I'm going to re-upload one more time in front of you in the class itself at the end of the class. Okay, it's already uploaded. Just wait for another few minutes. In front of you only, I will upload everything and I will take the confirmation from you that class it is available or not. Then only I will close the session. Okay, today. Okay, Anwar, let me cross check. I have uploaded in the last class itself for two remaining two batches. When I have uploaded, it was uploaded even for you. But since you are saying that it is not uploaded, let me re-upload one more time. And you have to confirm me at the end whether you are able to see or not. Right? Done. Okay. Next, coming to the bias variance trade-off. So as we have seen, bias variance trade-off means bias means nothing but here training is good. What are the training is there? Training is bad, but testing is good. Testing is good. test result is good, but training is bad. So what is the meaning of training is bad? Means either train accuracy is low. Training is bad meaning is train accuracy is low when compared to test accuracy. Second, or you are having the high train error. Accuracy is low means error is more. High train error. High train error is also called as bias. So whenever you are having this kind of problem, and this problem only we call it as underfitting. Training is bad. Underfitting problem. Okay. So whenever you are having the high bias models, you will face the underfitting problem. Underfitting means training is bad. Training is bad means train accuracy is low when compared to test accuracy, or high train error. For classification projects, accuracy. For regression projects, error. Next, coming to the high variance. High variance. High variance means nothing but just opposite to this. Whatever you are having here, just opposite to this is called as high variance, which is nothing but overfitting problem, where training is good, means train accuracy is good, but testing is bad. Okay, train accuracy is good and you are having the low train error. Training is good, but testing is problem. So these are the two different types of problem we are having. So coming to this bias variance trade-off. In the bias variance trade-off, we are having the total 4 possibilities are there. What are those 4 possibilities? The first possibility is so here bias. So low bias, low variance, high bias, high variance at the same time. Okay. So this is first one. Low bias, low variance. Low bias, high variance. High bias, low variance. High bias, high variance. Sir, what is this diagram meaning? So here I'm going to show you this meaning and I will just explain with a small example. Okay, so let me explain with a small example. Here, assume there are some dots are there. The dots are nothing but a person is shooting some arrow. Okay, let's assume this is some kind of shooting an arrow. Now, in this case, what are the data points he has shooted? Okay, what are the arrow he has shooted? These are the points. Gun shooting or arrow shooting, whatever it is. These are the points. The distance between the points. What is the distance between the points? Distance between the points is high or low, miss? So low. The distance between the points is low, which we call it as low variance. In this case and in this case. In these two cases, low variance is there. Miss the distance between the points. If the distance between the points is high, then they are called as high variance. If the distance is high. If the distance between the points is low. For example, now let us take an example like this. There is one student, he has got the marks in the test 1. In the test 1, he has got the marks of 80. In the test 2, 81. In the test 3, 90. In the test 4, 85. In the test, in the subject 6, subject or test or whatever it is. Okay, some marks you have got something like this. Okay, now between the points, what are the between the subjects, between the subject marks or between the same subject multiple test, what are the marks you are having? Here, let's observe the values. Between the values, the distance between them is high or low. High or low means it is called as low. We call it as low variance. For example, distance between the marks like this. One subject 80, another subject 40. In another subject 10 only. In one subject 100. In one subject 0. In one subject again 50. Something you are having. Now in this case, what happens? The distance between the points is very high. We call it as this one as high variance. This is low variance. Now, there is one more example, same way. Distance between the points, for example, one student has got 22, 23, 28, 25, 26, 21. In this case, distance between the points is high or low? It is low. So what this kind of, it is called as low variance. This is also called as low variance. This is also called as low variance. Then what is the difference between these two? Miss, to the actual marks, that is 100 as the actual marks. With the actual marks, it is having the high bias. With that, it is having the low bias. So though there is a distance between the data points is low also, low variance, and with the target, close to the target. Target is nothing but test. Close to the target. What are the target you are having? Since they are very close, they are called as low bias. So here distance between the data points is very high, but they are close to the target. Here distance between the data points is low, but they are far to the target. Far. So which of the data points are far from the target? They are high bias. Now out of these four, which one is good, miss? A good model has low bias, low variance. What about this one, miss? High variance is there. Maybe you are shooting close to the target, but the distance between the points are also very high. So this is high variance model. Here, all the points are very close to each other, but it is far from the target. So it is called as high bias. So this is high bias, high variance. This is worst model. We cannot do anything in this. At least here, okay, if this person, whoever the person is trying to shoot, okay, he knows what is the target and he knows at least some of the data points. He requires the more practice here. Because if he is trying to do on the luck or something, okay, then in this case, at least none of the data point will be close to the target. Here in this case, what happened is this person lacks the practice. So he requires the more practice. Whereas this is the case, he is focusing on different data point. Here focus level. So what are the gun position or arrow position? Just he has to change the position. The holding position he has to change. So at least if you change something, perfect answer will be there. At least if you change something, perfect answer will be there. In this case, nothing. So this is a worst model. So which is a good model means low bias, low variance is a good model. High bias with high variance. This is worst model. We cannot do anything with this. But a low bias with high variance, which we call it as overfitting. As I already told you, high variance. High variance means overfitting. High bias means underfitting. Training is not proper. If you train him to shoot here exactly, he will shoot there only. Training is not proper here. Here, practice is not proper. Okay, so here we can do something and we can do the betterization. This is the diagram indication where the data points between them is very high. Second, one more diagram also we are having. What is this diagram indicates means as model complexity increases. What is meant by model complexity means number of slopes. Model complexity means equation size, the size of the equation. Already in the nonlinear regression we have discussed. When you are increasing the higher degree of 2, degree of 3, degree of 4, once you try to increase the degree, what happens? Number of columns increases. Number of columns increases means what is the meaning? Number of slopes increases. Beta values increases. When the beta values increases, model complexity increases. So when the model complexity increases, what happens means train error decreases. There is no problem with the train error. What happens means test error will be high. As the complexity increases, variance increases. Variance means what? Test accuracy will be low. So in the non-linear regression, as the model complexity increases, variance increases. As you decrease the model complexity, high bias will be there. Bias will be top. If you increase model complexity, this will be top. So we have to identify the optimum degree. So we don't want too much of train error. We don't want the too much of test error. We want a good model which is good in the both of them. Point is clear? So Here again I'm going to explain with a small example. Make a note. First one is low bias. Don't write now. I'll give the time to write. Don't write now. First let me write. First I require the low bias, low variance. Second possibility is low bias with high variance. Third possibility is high bias. What are the high bias is there? High bias with low variance. Next possibility is high bias with high variance. So these are the four possibilities. Now, train accuracy, I'm writing in terms of accuracy wise. Test accuracy wise. I'm writing from the accuracy point of view. Error is opposite to that. Now, so here I'm having the low variance, low bias. Means here, for example, this is 75 and this is also 76 or 77 or 78 or something. Then this will be the difference between them is low. It is called as good model. Difference I want. The difference between train and test accuracy. Here low bias. Low bias means what I told you, low bias means low error. Which one will have the low error? Train error. But test error will be high. So opposite to that is instead of error wise, or you want to for the regression project, unnecessarily why to write for classification. Let me write for the regression only. Better to write in the regression only. Let me write. So for regression projects, assume RMSE. I got the RMSE. So for regression projects, RMSE I got here as some 56. Here my RMSE is 58. This is my RMSE value. Okay, 58.2 or 50, what are the value? So if RMSE value within the plus or minus 5% range, it is a good model. Now RMSE is low here. RMSE is 50 only, 56 or something. But here you are having the 75. This is RMSE. Train RMSE, test RMSE. I'm writing RMSE. So now in this case, what happened? Bias is low. What is meant by bias? Train error. The train error is low. The train error is low here. Low bias means low train error. Bias means train error. For regression projects, bias means train error. For bias, for the regression projects, variance means test error. Error means RMSE. Okay, wherever the word bias is there, replace with error. Train RMSE. For regression projects, it is RMSE. Okay, here you are having the 60. At the same time, here you are having the, or here you are having the 56, same 56. But here you are having in terms of 40. Then it is also called as bad model. This is called as bad model. And this is called as bad model. And this is also called as bad model. Now, high bias means this is also 56. And this one is 100 or something. Okay. So here you are having the high train error, high test error. And this is also called as a bad model. So out of 4 of them, only one of them is good. The difference between the train and test should be between the plus or minus 5% range. Now, generally what happens in the case of more examples, when you are trying to explain to the students more number of examples or more projects in the class, when you try to explain, when we train more number of examples, okay, more number of examples or more number of projects in class itself, what happens means the training will be good. And students also will give a very good feedback at the end. Sir has explained so many projects in the class. Sir has explained this one, that one, like this. The students will be giving the very good feedback. And whenever we make the spoon feeding, for example, without writing this notepad, if I share directly the notepad in the Google Drive, some of the students may say that, sir, you will provide the entire notes for us very clearly, something they'll say. Training will be good. Okay, train accuracy will be very high, training will be good, and everything will be good. And when I'm trying to explain the more examples, the concepts will be clear. The concepts, what are the concepts are there, it will be very clear. But the problem is when you're trying on the new data, okay, when you're trying on the new projects, then only you'll face the problem. And you will say that, miss, this is the problem is where some of the students will face this problem. Maybe in that you are also one of them in the future. Some of the students will face this problem and they are going to say at the end, their dialogue is going to be this one. Okay, at the end, some students' dialogue. What is the dialogue is? Sir, in class, everything is clear, sir. Whatever you are explaining is clear. But when we try, we are getting problems. We are getting problems. This is one of the statement. Second, some students after clearing the interview, they'll join in the company, Okay, after joining in company, okay, they will connect to me and they'll ask like this. Sir, you have explained everything, but here I have got the new project. Where to start? What you explained in the class is different. What was we are doing in the company is going to be different. This problem only we call it as, whoever are going to say this one, those students are called as war fitting problem. Means because you focused on example rather than concept, you focused on the example, and which has given you the war fitting problem later. You are trying to focus the example. That example will be always clear. So whenever we train the more examples now, automatically the training will be more clear. But when we try on the new data only, the problem starts. So similarly here also, okay, in the non-linear regression, what happens in the non-linear regression? Linear and non-linear both are same degree only na? As degree increases, simply I'm writing, as degree increases, the model complexity increases. Model complexity increases. Model complexity increases means that is nothing but number of unknown parameters. What are the beta values are there na? Unknown values. Number of unknown values, that is nothing but in bracket beta, is high or will increase. As degree increases, automatically beta increases. Beta increases. Okay, number of unknown values, that is nothing but beta or slope. In some other way, it is called as slope. As slope increases, the model complexity increasing means number of unknowns increases. So more amount of max will come into picture. Okay. Now in this case, what happens means as the data, what are the data is there now? With this data, train error always decreases. Train error always decreases. How many times you increase the degree, train error always decreases this. As degree increases, your train error always decreases. It will never increase. It will decrease because equation becomes more complex now. More complex. Now tell me, if I explain in the class, instead of 2 regression projects, if I take 3 months of additional time and if 3 months also I'm explaining regression only, 10 projects I have covered. Every weekend, one project of regression, end-to-end project we have taken. Like that, 10 weekends I have taken. 10 weekends, 10 projects I have covered. Now in the regression, what happens? More number of projects. Train accuracy increases or decreases for you? Increases. Now, you have not, when you're going to apply on the new data, what happens? Similar kind you will expect. Now, too much of projects will lead to the war-fitting problem. Too much of projects or too much of examples. So at the same time, if you don't even explain one project also, student will not understand how to implement. So we have to identify the optimum value. Too much of projects or too much of examples is not correct. At the same time, zero examples are also not correct. So we have to identify the optimum value. For some students, 1 hour is correct. For some students, 3 hours preparation is also not sufficient. For one student, half an hour is also sufficient. So here, half an hour is correct, 3 hours, 4 hours is correct, miss? Which one is correct, miss? It all depends on the students. Same way, degree of 1 is correct, degree of 2 is correct, miss? It all depends on the data set. Is the point is clear? As degree increases, train error always decreases. Train error always decreases means what happens? Low variance. Low bias. Bias will be low. But the problem is what? Problem is you are going to get the high variance. Bias you have decreased. You are not focusing on the output. Test error you are not focusing. You are completely focusing on the train error. Now the problem is high variance. Is that clear, guys? Everyone, high variance, which is called as war-fitting. Now the next concept, what are we are going to discuss? This one only. How to reduce this war-fitting. So to reduce that war-fitting problem, they came with a solution. What is the solution they came with, miss? Which we call it as regularization to reduce the overfitting problem. In regression projects. Solution is regularization. Solution is regularization. It will reduce the overfitting problem. What are the overfitting problem? Overfitting means what? Training is very, very, very good. Testing only it is going to fail. Okay. So this is called as regularization. So now in the regularization, what happens? So here, what are the problem is there? Now I will tell you with a small example, guys, where you have to think of how we can apply regularization. There are some students are there. Okay. This, if you understand this logic, that logic is directly relevant to regularization. You only have to tell me the answer. Some students are there in class. So approximately, let us take 200 students are there. Approximately 200 students. Okay, 200 students are there in class. Okay, in that, some of them are very talented. Okay, some of the students are very talented and they are getting the very good marks. Very good marks in local test. Means whoever are conducting the test. For example, my students only, let's consider. In that, some of the students are getting the very good score. Okay, in the local test. And some of the students are not getting the good score. Obviously, in the class, every student will not be talented. Na? So some of them are very weak. Some of the students are weak. And they are getting the bad score, bad marks in local test. Okay. Now, as a trainer, I have observed this. Some students are doing very good in my test. Some students are not performing very good in my test. I have observed. Now, after observing this one as a trainer, now these students are going to face the real world challenge. Okay, in the local test only, na? Now the test is going to get conducted outside. What are the test is there? Test will be conducted outside. Now, in the students are going to write the exam outside, that is interview. My students has to perform very well. But the problem is, my students are very good, having the very good marks in the local test wise. Okay, how these people are going to conduct outside? I'm a bit worried because here they are by hearting. I'm feeling that they are by hearting the concepts because they are writing as is whatever was explained in the class. Okay, I'm a bit worried about these students. Now, what to do? Anyone, any suggestion for me? Two problems I have to rectify. What are the two problems, miss? What are the problem? I'm assuming, I'm feeling. I also don't know whether they'll get once they go outside, whether they get the overfitting problem or not. I also don't know. I'm feeling that these students are having the very good marks in the local test. If they don't perform outside, miss, it is going to lead to the problem. At the same time, I'm having the sum of the students who are very weak. I have to increase their marks. This is my intention. Two things has to be completed. That one and this one. Anyone can give me some suggestion? What I have to do as a trainer? Anyone? Take some real-time example and end-to-end project. This problem will resolve the issue. Ganesh is saying that take some real-time example, end-to-end project. Okay, if I take end-to-end project, how it will be resolved? Ganesh, in what case? In what way? Train them separately, dividing into two halves. Okay. Increase more train data. This is one way. Okay. Okay. If I increase the train data, now obviously if I increase the train data or more number of examples or these weak students, they may understand the subject. But these people, whether they are performing outside well or not, how to know? So the point is here, understand this logic. Okay, understand this logic. Now I'm going to combine these two students as groups. Whoever the top student is there, na? One top student plus one weak student. Now, when this top student is going to explain to this weak student, how they'll explain each other. So concept wise, he'll explain. Now, he is going to explain all the concepts. He will explain all the concepts to the weak student. Now, obviously, weak student is not having the subject now. Obviously, he'll ask that doubts, right? When he is asking the doubts, what are the doubts are there? Okay, what are the doubts are there? This person is going to solve that doubts. Now, when he is focusing on that particular doubts, automatically, he will be getting the more concept clear, right? Now, automatically, the by heart will be reduced now. If he has by-hearted, for example, he has by-hearted one equation, how he will explain to other student? Array, this is this one only, by-heart like that. First it will come, next it will come, this next it will come. He will not explain why. But the weak student will ask why. Why it will come like that? What is the reason? And without by-hearting, how to understand this one? So now this student starts explaining very clearly. When the student starts explaining very clearly to the weak student, automatically his concepts will be very clear. This person concepts will be more clear. Okay. At the same time, he will also understand the detailness slowly because other person who is explaining is also a student only now. Now he is not having any kind of fear. Friend only now. Same class, same, everything is same, right? So he can discuss as a friend. Now here what happens? This person will increase the subject, and this person is going to increase the concept. So once the concept is clear, there is no requirement of by heart now. Never the person will by heart. When the by heart will be coming miss, only in the case of. So when you're going to write the exact as it is, what are in the class I have told you the sentence. When you're going to write as it is the same sentence miss, when it is not properly clear for you. When you write your own sentences miss, when everything is very clear for you. Point is clear. Example is clear. Understood or not? Same thing was happened in my real life. In my real life, I have faced this situation. Right? So here, this concept only called as regularization. This concept basically called as regularization, guys. Adding the weakness to the top one is called as regularization. I'll show you with an example. Before to that, so as I've told you now, to make the concept more simplified for you, just I'm going out of for 2 minutes, just only for 2 minutes, guys. I'll not take much time. So here, what happened in my real life? Okay, when we are studying, okay, when I'm studying the 12th class, okay, at that time automatically we are having the exams, right? Intermediate board exams will be there. Now we are in the session 1, and in the other session some other students are there. Okay, and what are the college I'm studying? Some college. What are the college I'm studying? Don't ask me the question why. I mean, why I'm explaining all these things. Don't ask that question. At the end, automatically you'll understand. Just wait for 2 minutes. You'll understand everything. When I'm studying in this college, okay, my college wants the student names on the paper. At the time, they used to publish state first, state second, like this. Of course, still it is continuing today also. They used to publish. Now I'm in that particular college. Okay, in that college, they have selected some students and they want to give more amount of focus on these students, and they want to make these students to get the top 50 ranks, and they want to publish on the paper, and they want to get the more money through them. Next year admissions, they want to increase by collecting the more money, and they want to showcase 1, 1, 1, 2, 2, 2 on the TV or in the newspaper. So I'm in this top 50. Okay. Now we are by hearting in such a way, and of course my rank is top 8, state 8. My rank is at the time. So at the time when we are by hearting or when we are practicing or something, okay, everything was going on. Okay. Now at that time, my principal, whoever the principal is there, he has got one doubt. These people are by hearting temporarily. Suddenly, if on one day if they forget miss, it is going to be a problem. I think these students are by hearting or they're really understanding the concepts and they're getting the marks. He has got a doubt. For that, what he has done is, at that time we are staying in the hostel. When we are staying in the hostel, okay, every weekend we require some permission to go outside. Okay, without permission, parents has to call or something. Otherwise, they used not to send the outside. We are staying in the hostel at that time. And what my principal has done is, okay, we will create a groups. Every group has to perform very well. And they have created how many groups? 50 groups. 50 groups. Now in that 50 groups, whoever the top 1 student, they attach it to the top weak student. Like that, they have created the groups. 1 top student plus 1 weak student who is very low in the subject marks. They have combined. And he has given one offer for us. What is the offer he has given is, in this 50 groups, who are the top 10 groups are there. Okay, I will give the outing. What are the outing you want? Without permission. He has told that I will give the outing without permission. At the same time, he has given that I will only sponsor for the movie for 10 groups. Okay. Now what happened in this case? Suddenly these top students, who are the top students are there now, they started explaining to the weak students, at least tomorrow you write in the exam very well. Don't miss this one so that we can go outside. Something. And they have started explaining the concepts very clearly. Now these people has got the concepts clearly, and these people also has got the concepts clearly. Finally, here for these students, whoever the top students are there now, when they have started explaining, their concepts are very clear and it has reduced their overfitting problem. That is nothing but by-heartedness, which was completely reduced. At that time, I don't know what is the technique he is applying and what is the reason he is doing that one. We don't know. My mind is only with the outing we are going to get, movie we are going to get. Only this interest we are having. But this concept only regularization, guys. Now I will show you the regularization. Now automatically correlate these two. You will understand automatically very easily. Okay. Remember this example and try to correlate so that you will understand. Regularization majorly used to minimize the model complexity. What is meant by minimizing model complexity means instead of going with the higher degree and increasing the number of slopes, within the less number of slopes only, how to get the maximum accuracy. It penalizes the loss function. What is meant by loss function means error. We call it as error. The loss function means loss. Loss means which one has to be less. Which one has to be less means error. So which is nothing but RMSE. So loss function we call it as RMSE. So penalizing means decreasing the loss function. Reducing the model overfitting problem, adding the more bias to the variance. Means what happened here? Already model variance is high. Model variance means what? That is overfitting problem. Variance will be high now. Already I told you, right? When the variance is high, here what he has done is one side he has increased, other side he has decreased. Now everyone, can you tell me here? This is a overfitting problem, which we got as high variance. High variance means what? Test RMS is very high. Now the difference between these two is very high. Now what I'm going to do is, one side I will increase the error. One side I will increase. Which side I will increase? Trying side I will increase the error. Instead of decreasing, I will increase the error. Other side I will decrease the error. One side I will increase, other side I will decrease. So this side I will decrease. One side increase, other side decrease. This concept is called as regularization and finally balancing both of them. Understood or not? Understood or not? So here, what are this problem is there? High variance problem. This is the high variance. What are the high variance models we are having? That is train RMSE and test RMSE. I am increasing the train RMSE and decreasing the test RMSE. Sir, why sir? Instead of that, keep the train RMSE as it is and you focus only how to reduce the test RMSE and how to bring this one to 57 or something close to that. Why you are increasing this side? Why you are decreasing? Why you are increasing? This concept of increasing one side and decreasing one side is called as regularization. Without decreasing this one is called as another concept. That is later which we are going to discuss. So there are different ways are there to reduce the overfitting problem. In that, one of them is regularization. One of them. Okay, in the regularization, what happens? Literally. Now, tell me guys, what happens in the regularization? As I've told you just now. In the regularization, train RMSE increases and test RMSE decreases. And finally, both will be equal. Close to the, finally, both now will be equal. Understood or not? Yes or no? Regularization will work in that way. Okay, where regularization is nothing but this. Okay, so train RMSE. Okay, train RMSE we are going to increase. Test RMSE we are going to try to decrease. See, if you are already having the accuracy, we know how to reduce that. Yes. So we are going to use the regression in real time, not the linear regression. Point is very simple. Again, Avinash is asking the question. What is Avinash question is? So here you are saying that, okay, here you are saying that non-linear regression, as the degree increases, the equation becomes more complex and leads to the overfitting. So we are going to use the regression. Exactly. So not the linear regression in the reality. Yes or no, miss? Answer is no. For example, let us assume this one. The data is like this. 1, 2, 3, 4, 5. Okay, 1, 4, 9, 16, 25. This is the data. Now for this data, if I apply the non-linear regression, I will get the RMSE is equal to 0. The least error I will get with non-linear regression of degree 2. When I am going to apply this one with a degree of 2, RMS will become the 0. For example, if I apply the regression, assume if I apply the regression, okay, then what are the equation I have received here? Along with that, RMSE also will come now. Now, if the RMSE is, for example, 2 or something, which RMSE is low? Non-linear regression or regression, which RMSE is low? So it's all depends on the data set. So for the given data set, we have to apply all the possibilities. Is the point is clear? Avinash. Next, Nazir. Is it always train data increases and test data decreases? And we can decrease the train data, not data. It is not data, it is accuracy. Accuracy or error, not data. Data means number of records. Regression is not used for the underfitting problem. No, it is only used for overfitting problem. Only for the overfitting problem. Not for underfitting. Only for overfitting. Okay. So here, the overfitting problem will be reduced by this one, by additional bias. This is only important point. How it is going to reduce? Reduce the model overfitting problem by adding some additional bias. This point is more important. By adding some additional bias. What is that bias? Let's understand. Could anyone tell me? Here I am having the one x, single x and single y. This is nothing but simple regression project. Now everyone tell me, for linear regression, what is the equation? What is the equation for the linear regression? What is the equation for the linear regression? When you are having the only one input column. Okay, y is equal to, can I write like this? Beta 1 x plus beta naught. Is that fine? This is my linear regression. Perfect. Next. Now, in this linear regression, how you are going to calculate the beta 1 and beta naught? Within the linear regression, how? How you are going to calculate? On what criteria? Means sum of the squares of error should be minimum. That one only not? That is nothing but sigma of y minus beta 1x minus beta naught whole square should be minimum. Here, what are the y hat is there? That is nothing but linear regression. It should be minimum. Okay. So for any regression project, what are the slopes and intercepts will be calculated only on one concept called as sum of the squares of error should be minimum, which is nothing but OLS technique. Here, as for linear regression or non-linear regression or any other regression, Equation changes, but finally the concept will remain same. The error should be minimum, right? Now in the linear regression, what happened? This is going to be. Now tell me non-linear regression with the degree of 2. With the degree of 2. What is the equation, guys? Beta 1 x squared plus beta 2 x plus beta naught. Done? Now from this, how you are going to calculate beta 1 and beta 2 and beta naught means sum of the squares. That is y minus beta 1 x square minus beta 2 x minus beta naught should be minimum. What are the equation? Y minus y hat whole square should be minimum. Now for non-linear regression of degree 3, what is the equation, miss? Beta 1 x cube plus beta 2 x square plus beta 3 x plus beta naught. How you are going to calculate these 4 values? Beta 1, beta 2, beta 3 such a way that their error should be minimum. What are the error is there? That one should be minimum. Right? Now, here non-linear regression. From linear regression, non-linear regression has came. This is one scientist has told. What this scientist has told means increase to higher degree. Everyone please write this one. Order of invention. Order of invention in regression projects. Within the regression projects, what is the order of invention? First, scientist one has invented one model called as average model. The first one they have started with the average model. Scientist one, whoever the scientist one or statistician or whatever it is, the first they have invented is average model. I'll explain what is this average model also in the next few minutes. Second, they have invented linear regression model. Instead of average model, they went to the linear regression. And from linear regression, they went to the non-linear regression. Why they'll go miss? Obviously, in the previous one, some problem has to be there, right? Without problem, why they'll go to the next one? They have observed in some data sets something is working, in some data sets something is not working. So in which data sets something is not working, from that they came with a new one. For example, today you have observed the ChatGPT. In the ChatGPT, you have observed some mistakes. Assume. What you are going to do? A new product you are going to develop by observing the mistakes of ChatGPT. Every case ChatGPT may not work properly. That is only called as mistake, right? So in which cases that ChatGPT is getting failed, how to rectify that problem and how to invent the new product. That is the next one. Like that, product to product, every product will be developed. Present, what are the Android version you are using? The Google has developed that Android model and the Android version. How, when you are going to get the next version is by observing the problems in this present version. That will be rectified in the next version. Like that. Upgradation. Every time upgradation. So now in the previous model, they have observed something problem and they came with the solution called as regression. Like this, they have started inventing. Now in the linear regression, what is the problem they have observed? What is the problem? In the linear regression, some problem is there. What is the problem they have observed to create the new one? Miss, the problem they have observed is low accuracy. Okay, they are getting the low accuracy for certain data sets. For certain data sets, they are getting the low accuracy. For certain data sets, it is doing better. It is doing good. For certain data sets, it is doing good. For certain data sets, it is not doing the good. Okay. For certain data sets, it is performing well. For certain data sets, it is not performing well. Now, so for this problem, they came with the solution. What is the solution is? Okay, you are having the problem this one now. Okay, I will give the solution where accuracy increases. They have increased the accuracy. After that, when they have observed that accuracy is increasing, but though model complexity increases also, accuracy is increasing. Though this one is increasing also, it is increasing. Nice. But one more scientist has asked the question, hey, you are always focusing on the train accuracy. What about the test accuracy? The problem they have observed is test accuracy was problem. Test accuracy is low. You are focusing on the train accuracy only. What about the test accuracy? Test accuracy is suddenly low is there. Now, when they have observed this model complexity problem, that is nothing but train accuracy increases, but test accuracy is getting low. Now, how to rectify this problem? Means they came with a new solution. Like that, they have invented one by one. Point is clear? They came with the solution. All these things are started with the first certain data sets, not for every data set, everything. That is a starting step. For certain data sets, linear regression is not working. They applied the non-linear. Again, in the certain non-linear data sets, test accuracy is very low, train accuracy is very high. Then they came with the new solution, how to reduce. Now, so here we are having this one now. How they have came with the non-linear regression means, let us increase the, what increase? Let us increase the higher degree of x and create the equation. That is the solution they came. But the person who came with the solution with the degradation, what are he is going to say is, no, here you are having the two problems in the non-linear. The first problem is complexity was increased. That is one problem is. Second one is overfitting problem is there. Now, I will come with the new answer, which we call it as regularization. A new one called as regularization. In this regularization, two problems. What are the two problems you have faced? In the non-linear regression, both of them will be rectified. What are the two problems? Model complexity increased. Problem 1. Model complexity increases. Problem 2. Test accuracy is low. These are the two problems. Then they came with the solution. Again, what is the solution? Means I will decrease the complexity. Model complexity. What is meant by model complexity? I'm using the word complexity. What is the meaning of complexity? Means less number of slopes. Model complexity increases means more number of slopes. Equation is bigger. Big equation. Okay. Point is clear, guys. Now, here they came with the solution called as, I will decrease the model complexity at the same time, plus I will decrease the overfitting. Plus decrease the overfitting. Both of them. I will do both of them. Both of them will be, problem will be solved. So what are the complexity is there? That one and this one. Okay. Now, how it will be solved means, so here earlier I told you now, in the nonlinear regression, what happens? Equation is bigger. Now in the regularization, equation will be as it is, beta 1x plus beta naught. For one column, how many slopes? Only one slope. You no need to increase the slopes. Keep the number of slopes as it is. So problem 1 was solved. What is the problem? Model complexity problem. Whatever you have got in the nonlinear regression, it was solved. So here you are going to have only one slope, one intercept. First one. Okay. But what they have done is the calculation of beta 1 and beta naught, not only this one, that is sum of the squares of errors, not only minimum, plus I am going to add some bias. Some bias I am going to add. This bias, including overall, should be minimum. Point is clear? So they have not touched the equation. They have kept the equation as is, but the calculation of beta 1 and beta naught, they have changed it to instead of sum of the squares of errors minimum, I want sum of the squares of minimum plus bias to be minimum, plus bias. So they have brought some additional bias. So here I told you now, requires some additional bias. So this additional bias only. Sir, what is this additional bias? That one only concept, which we are going to discuss now. So what is this bias and what is this everything? We are going to understand one by one. Okay. So here they brought with the bias. Yes. To remove the variance. This bias only. This is a top student, weak student. Earlier I told you one example now. One weak student they have added. After adding that weak student, total how many groups are created? Earlier I told you how many groups are created? 50 groups are created. In that 50 groups, okay, total 50 groups are created now. In that 50 groups, how many groups they are selecting? Only 10 groups. Means at the same time, they want the minimum only. Added the bias, minimum error. Minimum error means maximum marks. Understood? Understood or not? They are not only integrating the top student plus weak student, overall group should be, error should be minimum. High marks should be there. Group wise now. Earlier I told you that example now, that is only this. They are adding one bias. Some bias they are adding. And they are asking the overall should be minimum. Now this bias only different to different. Here in the regularization, we are having the three types of regularization are there. The first one is called as L1 regularization. Second one is called as L2 regularization. Third one is called as combination of L1 and L2. That is lasso regression, ridge regression, elastic net regression. Please make a note of this. There are three types of regularization. Done? Now, so the difference between these three of them is okay. So in the linear regression, within the linear regression, we are going to have the sum of the squares of error is minimum. Whereas in the L1 regression, L1 in L2, the difference is sum of the squares of error plus alpha into slope square should be minimum. Now, everyone make a note of this. What I'm going to write on the screen. Just give me a minute. Okay. So sum of the squares of errors plus bias to be minimum I have written now. Please make a note. Lasso. Lasso. In the lasso, the sum of the squares of error plus alpha into modulus of sum of the slopes. What are the slopes are there now? That should be minimum. Alpha into sum of the slopes should be minimum. Okay, in the lasso regression, within the lasso regression, yeah, we'll take one example. Clearly, I'll explain. The bias of lasso is this one. The bias of ridge. What is the bias of ridge, miss? Sum of the squares of error plus alpha into slope square. Instead of modulus, slope square should be minimum. Slope square should be minimum. Is the point is clear? Now, let's take a one small example. Take this example, some x and y, you are having some values. Please understand clearly, later you write the example. Some values are there. Okay, some values are there. Now in these values, write some values. Now, first one is linear regression. I'll start with the linear regression, followed by lasso, followed by ridge. First, linear regression. In this linear regression, equation. First, I'm writing the equation. In everything, I will do the same. First, I'll write the equation. What is the equation? Beta 1x plus beta naught. Okay, this is the equation. Now, how to identify the unknown values? In this, what are the unknown values? X is unknown, huh? No, right? X is this values only, known, huh? Which is unknown? What are the unknown values here? Beta 1 and beta naught. So here, identify the beta naught and beta 1 such a way that sum of the squares of error should be minimum. That is y minus beta 1x minus beta naught whole square should be minimum. Okay, once you expand this one and you apply the dy by dx, automatically you are going to get the beta 1 and beta naught. The same thing which I have explained during the linear regression time. Everyone remember or not? Yes or no? Do you remember or not? First, you are going to expand this equation. After expanding this equation, you are going to apply the dy by dx. When you apply the dy by dx, automatically you will get the beta 1 and beta naught. Everyone remember or not? Yes or no? Yes? Done. Now, right? Now, same way, here I am having the x1, x2 and y. Three are there. Okay, now what is the equation, guys? First tell me equation. What is the equation in this case? Same linear regression. Equation. What is the equation? Y hat is equal to beta 1x plus beta naught. Now, sorry, beta 1 x1 plus beta 2 x2 plus beta naught. Right? Now, how many unknowns are there here? What are the unknowns? Beta 1, beta 2, beta naught. Three are there. Out of which two are slopes. One is intercept, common intercept in every case. Right? Now, in this, how to identify the beta 1 and beta 2? The equation. How to get? Y minus y hat whole square. What is y hat? Sigma of y minus y hat. This is entire y hat. If I substitute here, beta 1 x1 minus beta 2 x2 minus beta naught whole square. Okay, from this, you are going to calculate the beta 1, beta 2 and beta naught. Three of them you are going to calculate by expanding this one. In the similar way, you are going to expand this one. Earlier you have expanded that one. Now you are going to expand this one. Yes or no? Clear, everyone? If it is clear, please make a note of this one. After that, I will erase and I will write for the lasso in the same way. For simple regression project, I will write for the multi-regression project in the same way. So this is sum of the squares of errors is minimum. We require the sum of the squares of error minimum for linear regression. For linear regression, what we require? This one only. This is for linear regression. I require error should be minimum. Yes? Yes or no? Second example, multiple linear. Multilinear. Exactly, Nitish. Clear? Everyone has written step by step. For linear regression, this is main important. That is sum of the squares of error to be minimum. Now, let us move on to the same way. Let's take one x and one y. X and y. Some values of x and some values of y. Come to the lasso now. Lasso. Within the lasso, first equation. What is the equation is going to be, miss? Y hat is equal to beta 1x plus beta naught. That is only going to be the equation. There is no difference in the equation. Okay. Now, here what we have to identify? Identify the beta 1, beta naught. Same thing. In the linear regression, whatever you have written, same thing. No difference. Now the difference comes where sum of the errors plus bias. What is that bias? Alpha into modulus of slope. Alpha into modulus of slope should be minimum. That is nothing but sigma of y minus y hat whole square plus alpha into, here what is the slope? How many slopes are there here? Only one slope now. That is nothing but beta 1. So modulus of beta 1. What are the modulus of beta 1 is there? Including this one should be minimum. So my equation is like this. Y minus beta 1 x minus beta naught whole square plus alpha into modulus of beta 1. This one should be minimum. And from this, I'm going to calculate beta 1 and beta naught. When I expand this one, in this, how many unknowns are there? Beta 1 and beta naught only, na? Y we know, x we know. Sir, what about the alpha, sir? Alpha is not a fixed value. Alpha, we have to do the tuning. We have to try the different alpha values. This is not a fixed value. If alpha is equal to 0, linear regression. If alpha is equal to 0 means it is called as linear regression. We are going to try the alpha values with different. Alpha is equal to 1, alpha is equal to 2, alpha is equal to 3. Like this, we are going to try the different alpha values. Alpha is not fixed. We are going to try the different values. Right? Now, when it comes to the more than one input variable, x1, x2, and y. Now, in this case, what is the equation for lasso? Within the lasso, what is the equation? Means equation is y hat is equal to beta 1 x1 plus beta 2 x2 plus beta naught. So, what are the equation you have written in the linear regression? Same only. No difference. Equation is going to be the same only. No new equation. The calculation of beta 1, beta naught only varies. So here, sum of the squares of error plus alpha into modulus of slope to be minimum. But here, how many slopes are there? One slope or two slopes or three slopes are? How many are there? Two slopes are there. Sigma into y minus y hat whole square. I mean, y hat, I'm going to substitute. That is beta 1 x1 minus beta 2 x2 minus beta naught whole square plus alpha into beta 1 plus beta 2. So 2 are there, na? So 2 are there. Plus alpha into modulus of beta 1 plus modulus of beta 2. So alpha should be multiplied with the beta 1. Same alpha has to be multiplied with the beta 2 also. Here, if you observe in the PPT, I have written that word. Of course, this entire PPT I'll explain, guys. Just wait for another few minutes. So requires some additional bias. That word is clear now. That is nothing but alpha into modulus of beta. That is additional bias. Requires a such means identifying the best value. For optimum penalty hyperparameter, that is alpha, we have to identify the best alpha value. Different alpha values will be there. Within that different alpha values, you have to identify the best alpha value. Is the point is clear? And from this, you are going to calculate the beta 1, beta 2, and beta. What is hyperparameter? Hyperparameter means here alpha. What are the alpha is there? The parameter which is the part of the model. The parameter which is the part of model is called as hyperparameter. The model parameters. Understood or not? How many of you are clear? How many of you are not clear? Please tell me here. How many of you are not clear? I want not clear students. If you are clear, miss, well and good. If you are not clear, miss, whoever is not clear, write clearly in the notes, not clear. Mayur, there is no formula for alpha. Since alpha is not having the any formula or fixed value, we have to try the different values. We have to try the different values. Mayur, is your question is clear? RD. Explain the second formula in the right side. That is nothing but third line. 1, 2, 3. Yes. Here, sum of the squares of error. That is nothing but this is your linear regression. Up to here, it is linear. This is bias. So a linear regression plus bias. A linear regression plus bias. So here bias is alpha into modulus of slope. Here one slope is there, so one slope only. But here two slopes are there, na? So like that, alpha into modulus of slope 1 and alpha into modulus of slope 2. Like that, how many slopes are there? Everything you have to do. If you expand this one, alpha into modulus of slope 1 plus alpha into modulus of slope 2. Here, why you have written one slope means only one is there. Here, why you are writing 2 means 2 are there. Clear now? RD. 3 are there means 3. 4 are there means 4. 5 are there means 5. Yes. Clear now? Rakesh, why modulus is used? That is one way of technique. That is one type of technique. These are all the different techniques. Points are clear. And next, Ranjita, why we are adding the bias? To reduce the overfitting problem, na? Here beta was earlier the beta was calculated. The what are the beta 1 and beta naught was calculated. It has given the overfitting problem. Now automatically we are going to calculate the new beta. Now as the beta changes, RMS changes or not? If beta changes means RMS changes or not? Changes, right? As the equation changes, new predicted values will be there. That new predicted values, the difference between the original values, the error might be reduced. Instead of old beta 1 and beta naught, now we are trying the new beta 1, beta naught values. A new one. Whatever we have got the problem in the linear regression, now we are trying to rectify that. Ranjita, now it's clear? Next, coming to the similar way ridge. Now for ridge also, for simple regression project, that is X and Y, simple regression project. Similarly for multi-regression project. Ridge. Now for ridge, what is the equation miss? Y hat is equal to beta 1x plus beta naught. Now tell me guys, what you have observed between the linear, lasso, ridge, three of them. For simple regression project, what is the difference in the equation? What is the difference between the linear, lasso and ridge? For simple regression project, simple regression means one input variable. What is the difference between the equation? What is the difference? Here also beta 1 plus beta naught, beta 1x plus beta naught, beta 1x plus beta naught, beta 1x plus beta naught. Any difference is there? So equation is same only. The calculation for the beta 1 and beta naught changes. How to identify that beta 1, beta naught changes, but equation will remain same. Point is clear, guys. How to identify the beta 1 and beta naught, that is changing. That is sum of the squares of error plus alpha into slope square. Alpha into slope square. That is sigma of y minus beta 1 x minus beta naught whole square plus alpha into, here how many slopes are there? Only one slope, this one. So overall this one should be minimum. And from this we are going to calculate the beta 1 and beta naught. So a new beta 1 and beta naught is calculated when compared to linear regression. Understood or not? Everyone is clear now? Equation remains same, but the extraction of beta 1 and beta naught changes. Right. Done? Sir, is this is the form, not that formula. Now automatically when you extract now, it is not going to be compulsory here this one. In the beta 1 only, automatically beta 1 will be multiplied with something. Okay. Now, so here, what is the equation for reach now? Tell me equation. Y hat is equal to beta 1 x1 plus beta 2 x2 plus beta naught. Now, sum of y minus y hat whole square plus alpha into slope square. Now, sigma of y minus beta 1 x1 minus beta 2 x2 minus beta naught plus alpha into slope square. How many slopes are there? One slope, no, right? So beta 1 square plus alpha into beta 2 square. Earlier you have applied modulus. Now you are applying the square of the slope. Earlier bias is that one. This bias is this one. Only the bias changes. Is the point is clear? Everyone. Now, for example, you have to explain to another student. Your friend only you have to explain. For one student who is already having some knowledge, who attended the Saturday's class, for him explanation is different. The person whom you are explaining for the person who is not attended the class, Saturday's class, for him explaining is going to be different. Yes or no? Both the students will have the same doubts, sir. Both explanation will be the same, huh? Tell me, guys. Have you attended Saturday's class? Have you attended Saturday's class? No. Saturday you have not attended. Is that clear, guys? Everyone understood or not? What is the difference between the ridge and lasso? Right? Yes. Only difference is bias. The bias is different. The linear regression, ridge regression, lasso regression is same. Equation wise same. The calculation part of beta 1 and beta naught differs. Equation wise, everything are same. So now tell me, in this case, what happened? Now, when compared to non-linear regression, regularization model complexity decreases or increases? Which one is having the more complex? Non-linear regression or ridge or lasso? Which one is having the more complexity? Right? Yes. So now Abhinash is asking the question. If bias value is increasing, the equation becomes more complex. Why equation will become more complex? How equation will become more complex? Equation will remain this one only, na? In the equation, are you going to increase the number of slopes? This is called as model. Model will remain same only, right? Internal calculation only, na? I'm not asking about the internal calculation. It's clear, right? So model complexity means the number of slopes. Okay. So now this problem was solved. What are the problem you have got in the non-linear regression? It was solved. First one. Second one is overfitting problem also solved. So the model will remain same. The complexity will not increases. What are the complexity you are having in the linear regression? The same level of complexity will be there in the regularization. Only in the non-linear regression only it was increased. In between it was increased. It will remain same. Understood, everyone? Now, see, so that these regression methods has introduced an additional hyperparameter that need to be tuned. That is alpha. Alpha has to be tuned. Now, here a multiplier to the penalty, the strength of the penalty. That is alpha. What are the alpha you are trying to multiply now? The more number of alpha you are going to give, it will increase the problem. Now here, first I'm going to start with the L2. Why L2 means? Because the max behind that is easy to understand, that is square. So see here, ridge regression advantage is to avoid overfitting. What is our ultimate goal? Any regression project, what is the ultimate goal? As I've told you, RMSE to be low. What are the project to implement? Finally, RMSE should be low. Our ultimate model is to, which is able to work on the both training and test data. It has to work on the train and test data. It neither should work only exclusively on the train data. In the non-linear regression, what happened is train accuracy is very high. It is basically focusing on the train data. But my requirement is what? Train data, at the same time, testing also should be good. Overfitting occurs only when the problem comes, only when the model performs well on the train data. Training is very high, but testing is low. That is only called as overfitting, right? That is the problem. Now, ridge regression works by applying the penalty to overcome this. See, let's take an example like this. These three dots are train data. These dots are test data. Now, if I create one line, a linear line like this, it is going to pass from these three lines. When it is passing from these three lines, automatically, what is the train error? Anyone? What is the train error in this case? Error is going to be 0. Because it is passing through the lines, the data points now. The error will not be there. For example, if the points are here and line is passing, means this is the error. This is only point, in that only line is also there, means predicted value. This is line is nothing but predicted value. Point means actual value. The difference between them is error. when the line that is predicted values are passing over the actual data points, error is 0. So when I applied the least sum of squares applied, what is least sum of the squares means nothing but linear regression. When linear regression was applied on the best bit line, since the line is passing through the 3 data points, the sum of the errors is 0. Residuals means error. Residual means gap between the actual and predicted value. Okay, the gap between the original batch, the gap between the original value versus predicted value. What are the gap is there? That gap we call it as residual or error. Okay. Now guys, 7:30 batch, we are going to continue this one only. It will take another half an hour to 45 minutes. Ashvi. Right? Now, however, the testing data, the sum of the errors are very high. Now, in this case, what happened? Train error is very low, test error is very high due to this line. Point is clear. Overfitting problem clearly you can see due to this line. What is this line? Linear regression line. Due to the linear regression line, have you observed the train error? What is the train error is 0. Test error is this, everything is error only now. If you calculate the sum of the errors, automatically test error is very high. So test error is high, train error is low. What type of problem it is called as? Overfitting problem. Now, how to overcome this overfitting miss? See, slightly I am changing the slope. Slope was changed slightly. Means what are the earlier beta 1 value is there? Some beta 1 will be there now for this. This line is there, means some beta 1 will be there, right? Now, this beta 1 I am slightly changing. I am changing slightly the beta 1 value. Now, when I change the slightly the beta 1 value, what happens? Here, train error was added. Earlier it is 0 now. See, ridge regression works by attempting the increase in the bias. Now, by changing the slope of the line, the model performance may be little poor on the training set, because now error you will get. Earlier error is how much? Train error is 0. Now, some error is there. Slightly you added the error for the train data. But how much you have decreased in the test data? That is important. You are slightly adding. Train, it is maybe lightly poor on the training set, but it will perform consistently both on the training and testing. Point is clear? This change in the slope only. Earlier we calculated now. Now the new beta 1, beta naught will be calculated. Earlier I told you, right? Do you remember that one now? Everyone? Yes or no? Sir, still increase the slope, sir. Slightly still increase. Now what happens? Increase. First alpha is equal to 0. Alpha is equal to 0 means what is the meaning? Alpha is equal to 0 means what is the meaning? I told you. Linear regression, right? Means bias is not there now. Alpha is equal to 0 means 0 into beta. 0 into beta means 0 only. Means bias is not there. Without bias, what is this model is called as? Linear regression line. In the linear regression line, alpha was 1. Alpha is equal to 2. Alpha is equal to 3. As you increases the more alpha, it becomes the more horizontal. Once it becomes the more horizontal means there will be no difference in the predicted values. It will not even depend on the slope only. Point is clear? Too much of alpha will again be a problem. Understood or not? Now, please ask me what are the questions you are having in the ridge. Within the ridge, please ask me what are the questions you are having. Everyone, within the ridge, what are the problem you are having? What are the doubt you are having within the ridge? Please ask me now. When compared to linear regression, to reduce this overfitting problem, I got a new idea. The idea is I will change the slope and I will create a new line like this. When I create a new line like this, a new error will be created in the train. But my requirement is train. At the same time, test also has to be performed well. So when compared to linear regression, by changing the slope, I have drastically reduced the test error, but slightly I increased the train error. I increased slightly, but decreased is more. It's a good concept or bad concept? I'm not saying that I have not increased. I have increased. But how much I increased? 10 times I have decreased in another case. Then, sir, for example, you have increased 5 here, sir. There also you decreased 5 only. Then what is the use? There is no use. If I have increased only 5, but I have decreased 50, then 50 or 40 or 20 or something. How much you have increased, than that more you have decreased the error. It is a good one or bad one. So like that they have started. So the penalty term is nothing but alpha into slope square, where alpha is not fixed value. L2 regression adds the penalty equal to the square of the magnitude of coefficients. Coefficient means nothing but slopes. Square of the slopes. All coefficients are shrunk by the same factor. Means alpha into beta 1 square, alpha into beta 2 square, alpha into, if you are having third one, alpha into beta 3 square, means every slope has to be multiplied with the same value. Every coefficient, what are the coefficient is there? This one has to be multiplied with alpha, alpha. Every slope has to be multiplied. Slope of this, that is square of the slopes, has to be multiplied with the same. Everyone is clear or not? Yes or no? How many of you are not clear? Please type and ask what are the question you are having. So until the train and test RMSE values difference is low, we have to increase the alpha. Exactly. We also don't know what is the alpha value. We have to try different alpha values. We have to try. Like how we don't know the degree in the non-linear regression, same logic will be applied here. Now tell me guys, sigma of y minus y hat whole square plus alpha into slope square, I told you. This is called as ridge regression. Now if alpha is equal to 0, what happens? 0 into slope square. 0 into slope square means what? 0. Sigma of y minus y hat whole square only will be there. Sigma of y minus y hat whole square is called as what? A without bias. A model without bias is called as what? What model? Linear regression model. Is the point is clear? Yes, somewhere we referred it modulus. Somewhere we are doing this one. Okay. Sir, how this slope will be predicted here in the lasso regression or in the that calculation? Same thing. How we can know which regression has to be applied? Since we don't know, we have to apply both of them. We are going to apply for both of them. So what are the data set was provided to me? See here. In the next class, I'm going to show you. Here I'm having the data. I will take one data set. For the same data set, I will apply simple linear regression, polynomial regression, lasso, ridge, and elastic. All of them I'm going to apply on the single data set. Then that is only called as capstone project. Is the point is clear? The meaning of penalty. Penalty is nothing but bias. What are the extra bias you are adding? That is alpha into slope square. You are adding this one now. That is only penalty. Penalty term. Penalty means alpha into slope square. That is called as penalty. Point is clear. Right? Now, so lasso. What is the lasso means? Lasso regression is similar to ridge regression. Only difference is what are the penalty term is there? alpha into modulus of slope. The penalty term is alpha into modulus of slope. What are the penalty term you are going to add? So that is one type of logic. This is one type of logic. Everyone is clear? Alpha into modulus of slope. Right? Yes, Roshan. It is a name. Lasso regression. Lasso regression. I mean, you are asking the scientist name is Lasso, no? I don't know. It is a Lasso regression. Right? Now, so as alpha increases, in this case also same problem. So we have to see for alpha is equal to 1, what happens? For alpha is equal to 2, what happens? For alpha is equal to 3, what happens? We have to see. Sir, are we going to see manually one by one? For loop is there, right? Try the different alpha values for alpha in range of 1 to 10. Don't worry about the coding part. Right? Now, third one is, so linear regression, ridge regression, lasso regression. For the linear regression, sigma of y minus y hat whole square to be minimum. For this sigma of y minus y hat whole square plus alpha into slope also, alpha into slope square also should be minimum. A combination of both of them. For this sigma of y minus y hat whole square plus alpha into modulus of slope should be minimum. That is a difference. Finally, in everything, you are going to calculate beta 1 and beta naught only. Common. In everything, finally, the calculation of beta 1 and beta naught only differs. Clear, guys? Now, next one will come into picture. That is nothing but a combination of both L1 and L2. The third one is combining L1 and L2. So, what is L1? What is L1? Sigma of y minus y hat whole square plus alpha of modulus of slope. What is L2? Alpha of slope square, right? So this is lasso penalty, this is ridge penalty. Elastic net is both of them, a combination of both of them. Overall should be minimum. Overall should be minimum. A combination of lasso penalty plus ridge penalty. Both of them, a combination should be minimum. Sir, both of them, if you have double penalty, no, sir. So that is the reason what they have done in elastic net, y minus y hat whole square plus lasso penalty. What are the lasso penalties then? Lasso penalty plus ridge penalty. Overall should be minimum. But two penalties, if you add, double penalty will be there. For that, what they have done is, they have multiplied for this lambda 1 minus lambda. Suddenly, what is this lambda, sir? Very simple. For example, if lambda value is equal to 0, let's take lambda is equal to 0. What is the meaning of lambda is equal to 0? Miss 1 minus 0 is 1. Miss completely lasso penalty, ridge penalty will become the 0. Now only lasso will be there. No ridge will be there. When lambda is equal to 1, lasso will become 0, only ridge will be there. Now, if lambda value is equal to 0.1, 90% lasso, 10% ridge. Total 100% now. Penalties, what are the values there? Out of 100% of the penalty, I have given 90% penalty for lasso, 10% for the ridge. Lambda is equal to 0.2. Now, 80% lasso, 20% ridge. Lambda is equal to 0.3. 70% lasso, 30% ridge. Lambda is equal to 0.5. 50% lasso, 50% ridge. lambda is equal to 0.9. Lambda lasso is 10%, ridge is 90%. Lambda is equal to 1. Lasso is 0, ridge is 100%. So lambda value varies between 0 to 1 only. It cannot cross more than 1. It cannot be less than 0. The lambda will be between 0 to 1. Lambda is nothing but percentage of. How much percentage of lasso you are considering? How much percentage of lasso or how much percentage of ridge you are considering? So here, this is the equation. Okay. So how much percentage of lasso you are considering? So 1 minus alpha into ridge plus lambda into lasso. So lambda is equal to percentage of lasso. Percentage of lasso. Lambda is equal to 0 means the meaning is lasso is 0. Lasso should be 0. Lasso is 0 means this one should be 0. I don't want lasso. Lasso means modulus of slope should be 0. Percentage of lasso. Percentage of lasso is called as lambda. 1 minus lambda is percentage of ridge. Percentage of ridge. How much percentage of ridge? Now tell me, if I take lambda is equal to 10%. Lambda means what I told you? Percentage of lasso. 10% means what? 0.1. 10% means 0.1 only, right? So if I consider the lambda is equal to 0.1, what would be the ridge? 90%. That is 1 minus lambda is equal to 0.9, which is 90%. So 90% is ridge, 10% is lasso. Lambda is nothing but percentage of ridge. Sorry, percentage of lasso, lambda. Sir, why to take the lambda or why this one? Means if you don't consider the lambda or this one, assume this is not there. Then what happens? Double penalty will be there. This is 100% of this one. This is also 100%. Now 200% penalty, right? We call it as. Point is clear? So that is the reason. Now here alpha is not fixed. What is the any fixed formula is there for the alpha? Means for alpha no fixed formula. No, we have to try the different alpha. We have to try the different lambda. Both of them we have to try. In nonlinear regression, we have to try the degree. In nonlinear regression, we have to try the degree. Degree for nonlinear regression not fixed. Alpha value for lasso and ridge is not fixed. Alpha and lambda is not fixed for the elastic net. These are all not fixed. We have to try. Which are not fixed, we have to try. How to try means very simple. Give one value after one value, one value after one value. After giving each and every value, for everything you will get one output. Now you have to append that output, and from that you have to observe. If I do like this, what happens? Observe. If I do like this, what happens? Like that, what are the things you are going to do? In that, finally select the best one. It is called as trial and error method. It is called as trial and error method. Yes, in the next 10 minutes, I'm going to complete. 10-15 minutes max. Okay, just to give me 10 minutes only. 10-15 minutes. Ravi Kiran. Okay, just 10 minutes. 10-15. Maximum 15. 10 minutes max. Okay. Now, so make a note. Next one. What is the next concept is? Steps involved in the regression project. This one only we are going to do in the practical. Steps involved in regression project. What are the steps? Everyone, please make a note. Okay. First step is, okay. First, we are going to understand the project requirement. What exactly they are looking for to predict. First, we have to see this. What you want me to predict. Whether that variable is available in the data set or not. If it is available, if it is numeric or not. Like this, we have to check. Then only it is called as regression project. First, variable are not available in the data set means it is called as unlabeled data. Then it is not even called as regression project only. First, the whatever you are asking me to predict, it has to be available in the data set. Second, it should be numerical only. So that you have to understand very clearly. There only you have to decide whether it is a classification project, whether it is a regression project, whether it is a other project or anything, all these things. At the same time, you have to observe whether the data is in the numerical or, data is in the sequential order or non-sequential data. Where you observe all these things means in the step one only you have to observe. How, sir? Means I'll show you then two examples. I'll do two projects. One is simple regression project, one is multiple regression project. So two different projects when I'm going to do, I'll explain clearly. Same logic you also have to apply in every project. Second step. What is the second step I'm going to do means I'll explore the data. That is, we call it as data understanding. I'll understand each and every column name. Along with that, I'll do the data exploration. What is my second step? Data exploration. And in the third step, okay, I will do the data pre-processing. That is cleaning the data. Data cleaning. Or data transformations. I will do the data cleaning and data transformations. Two batch students already know this one. And morning 7:30 AM batch people don't know this one. So don't worry. We are going to work on this. You'll understand very easily. Up to here, everyone is okay? Now, what is the fourth step? Now, I'll divide the data into two parts. That is train, test, and split. First, I'll divide the data into two parts. So this is also part of data pre-processing only. I will divide the data. After dividing the data, then now I will do the apply how many models are applicable or how many algorithms are applicable for the given project. Apply all the models. Apply all models or all algorithms. Apply all models or all algorithms which are related to project. Everything you have to apply in the data cleaning. Part of the data cleaning. So apply all the models or all algorithms which are related. For example, simple regression project, simple linear, simple nonlinear, lasso, rich, elastic. Multi-regression project, then multilinear, multi-nonlinear, lasso, elastic, rich. So according to the given project, we have to apply every algorithm one by one. And we have to try the multiple models. We have to try the multiple models. Try multiple models. Not one or two. We are going to try multiple. Out of multiple, how many we have done? In this, all the models, every model, how many models you are going to have? Every model, evaluate. Evaluate means calculate, evaluate. That is nothing but calculate, train RMSE, calculate, train RMSE, and also test RMSE. How many of them are there? Every model. You tried that one means that one, this one means this one. Every model calculate, train and test RMSE. Then from all the models, from all models, how many models you have tried? From all models, select the best one. Select the best which has high or low error, which has low error with no problem. No problem is no underfitting, no overfitting should be there. So that is also called as good model, which has low error and a good model, which is a good model. From all the models, we are going to do this. This is only called as model selection. This step is called as model selection. So you are going to identify the best model from all your good models. From all your good models. Within all the good models, identify the best. Sir, what is this, sir? For example, linear regression you applied. Okay, train RMSE, test RMSE. Calculate the train test, both of them. From this, both of them conclude remarks. I'm writing here remarks. Whether it is a good or bad, good. When it is good, the difference between them is less than 5% good. Apply the non-linear regression with degree of 2. Trying to test I calculated. It is also good. Non-linear regression, degree of 3. Trying to test. It is a bad. Assume. Next, I have tried with the lasso. In the lasso also, I will calculate the train and test. It is bad. Ridge. I applied the ridge. What is meant by bad and what is meant by good? Good and bad is nothing but if the train and test RMS both are same is good model. If both of them are not same is bad model. Underfitting or overfitting are called as bad models. No underfitting, no overfitting are called as good models. There is a difference between the good versus bad. Good model means no overfitting, no underfitting. Next, ridge model. In the ridge model also, I'm going to calculate the train RMSE, test RMSE. Assume it is good. Elastic net. I'll apply the last one is elastic net. Train, test. And assume this is also bad. Or it is good. Let us take it is good. Assume. Let's take an example like this. Now, how many good models are there with you? Out of 6, you applied overall 6. Out of 6, how many good are there? 4 are there. This one, this one, this one, this one. For these two, no need to discuss also. Waste of time. Bad model, na, throw it. No need to discuss. Okay. Within the good models only, which is best? Which is best means out of all of them, which one is having the test RMSE highest? That is the best one. Test RMSE low. Error should be low now. Not high, low. Sorry, my mistake, low. Error should be always low. So for example, test RMSE is 56. Test RMSE is here 70. 45. This is also 45. Assume that you are having like this. Out of all of them, which is having the low test RMSE? Assume it is 42. Example 1 is 42. 4 good models are there. In the 4 good models, which is having the low test RMSE out of these 4? Elastic. Go with this. Sir, assume if this is also having the same, both of them same. You told that within the good models, check that low test RMSE, which is having the low test RMSE. Within the good models, within good models, which has low RMSE, that model is called as best model. Within the good models only. Don't compare with the bad models. Bad models are simply thrown. Sir, for example, train accuracy or train error. Train RMSE is 0, sir. Test RMSE is 100, sir. Now, should I consider this one? test RMSE 100 or 80 or something, or 500 or 600, something, some number. Should I consider this model or not? Sir, error is zero, no, sir. Error is zero in where? In trained. I don't want only trained. Sir, for example, test is 74, sir. Test is 0, sir. I don't want here also. I want to satisfy both of them. I want a good models. I don't want one-sided model, which will work only for test data or which will work only for train data. I want to work with both the models, both of them, both types of data has to be. Point is clear. Sir, test error is 0, no, sir. Test error is 0. Train. Tell me train also. You are focusing only on one. I am asking both. Sir, if two models are good at the same time, two models are good. Good means train and test is same. Train error, train RMSE is equal to test RMSE. Train RMSE is equal to test RMSE. Two models are there, good models. Two models are good. At the same time, both are having least RMSE. Both of them are having the least RMSE. In this case, which one has to be selected? Means which takes less time. Now, last priority goes to the time. First priority always least RMSE. When everything is same, same, means last priority goes to the time. Is the point is clear? Now tell me guys, if there is a student who went for the interview, assume that it is interview, and in the interview, he has got the test score, and this is the salary. This is the salary what he is expecting. Now the questions are on the ML, exclusively on the regression only. Assume it is regression interview. Now the student one, I asked 10 questions. Out of 10 questions, he answered 10 out of 10. And I asked, what is your expected salary? Miss, per annum, he told 24L. Student 2, 10 on 10. 10 on 10. Student 2 has given for me 9 on 10. Right? Student 3 has given me 0 on 10. But what is the salary he is expecting, Just 1 lakh per annum. Not even per month, annum only. Means literally I will write here 10K, sir, not even 10K, sir, 5K, sir. 5K per month. Only 5,000. But his score is 0. Are we going to select or not? Low salary, no, sir. What I have to do with this? Did I select it for Pune worker? No. To bring the files or to bring some tea or coffee, not for that purpose, right? For the regression project. But regression concept is 0 means what I have to do with this? Though his salary is also very low also. What I have to do? Okay. Now, no use. Even he asked 5,000 also, we can't pay. 5,000 per month also, they will not pay. Not even 1 rupee also. Waste na. We can train him, miss. If he trains, now already trained data, the project is ongoing in the company. Now you'll focus on training or on focusing on the completing the project and take the money from the client. You are not running the institute in the company, right? To train him. Point is clear? Now, assume there is a student 4. Student 3, I told you now. Now, student 4. He is also having the same 10 on 10. But he is expecting 15 lakhs only. Why, sir? Miss, he is having some problem like career gap. Some gap is there. So when there is some negative point, he is expecting only 15 lakhs. Now, student 5. 7 on 10 or 5 on 10. And he is expecting 8 lakhs. Now tell me, whom you are going to select in your company? Student 1, student 2, student 3. Which student? If you are the owner and you have to complete the project, and that project, if you submit only, you will get the money first. To pay that salary first, you have to get the money now. If you hire this person, he will not complete the project. When you will get that money, even 5,000 also you will not get, right? First to pay. First you have to pay means first you have to get the money, right? When you get the money, you will pay the salary. You will not get the money means from where you will pay the salary. Now tell me, which student? Two best models are there here. Two good models are there. Within the two good models, we have identified second priority goes automatically to the salary. So once you go for the interview, sir, I have performed very well, sir. I have done very well, sir. I have answered maximum number of questions, sir. But this they have not selected me, miss. Sometimes, like you, another person also might be available who has got selected with less salary. You are good. That is from your point. But he will not do the interview only for you, right? Similarly, here also, within the good models, first we have to always focus on the least RMSE. When that is same only, second priority goes to this one. Now here also in the interview, first they'll always give the priority for the score. Why scores are, why they'll not give the priority for the lakhs means, if I hire this 5 marks person, he is asking only 8 lakhs now. I can save 16 lakhs money. I get, 7 lakhs I can save when compared to him. Or he is asking only 4 lakhs. How much amount I can save? 11 lakhs I can save. When I can save that one means when he completes the project, 50% knowledge person will complete the project or not? 50% knowledge person will complete the project or not? If he can complete, why he'll have the 50% knowledge? Knowledge means what? How much he can capable of completing the project, only knowledge. He is not having the capability to complete the 100% project. What I have to do with that person? Then he will submit the project. He will complete the project or not? Yes or no? He cannot complete. When he cannot complete, can I get the money from the client or not? No. When I can't get the money, can I pay 4 lakhs or not? Now you tell me, without subject, should I hire the person with low salary or not? Similarly, here also, without accuracy, should I go with the least time model or accuracy wise I have to see? Time or accuracy, which one is priority? Marks or salary, which is priority? If you feel here marks means, there it is RMSE. Here if you feel salary means, there it is time is more important. That is very simple point. Completed. Everyone is clear? That's it. Completed. Now you can ask what are the questions you are having. If no questions, next Saturday, upcoming Saturday, we are going to do the project. All these things we are going to practical implement. I will show from the starting to ending till the model selection. Every step I will show you. For a single data set, I will show you everything. That is, we call it as end-to-end project. We will discuss that. Everyone? Yes. I'm going to share this recording for you. After the class, I'll share you the recording. As I've told you, by morning, you will receive the recording in your Google Drive. In the classroom. From my end, I'm going to share. 100% I'll share. Everyone is clear? Please ask first your questions. And after, before asking the questions, please give me 2 minutes of time. First, let me upload. And I will take the real-time data, which is having the practical importance. Okay. Ganesh, I'm going to take the real-time data sets. Both of them are real-time, which in the real case, I'll ask the company name also. You will only tell in the Saturday, you will tell which company will use that. Remember this. but I can't bring the exactly company's data. Internal values might be different, but usage will be real-time usage. Point is clear? Just give me 2 minutes of time. I will upload everything in that Google Drive. Please cross-check from every batch. Everyone, please cross-check. After cross-checking, once you say that everything is available, then only I will close. Otherwise, I will not close. Just to give me 2 minutes. First, let me upload. First, I have to upload, then I will confirm. Just to give me 2 minutes. I will be online only. And after your confirmation only, I will close the class. Yeah. I'm creating the folder clearly for your better understanding, easy understanding. Within the machine learning, again, I'm creating a separate folder called as regression. And within the regression, I'm going to add the complete nodes. Yeah, tomorrow the classes will be as usual. Okay, only today we have taken like this. Tomorrow again, everything is normal. Morning, evening 6, everything is normal. Just only for today's class. As the topic was pending in the last class, as you clearly you can see, right, how much time we have spent extra now, which will is not possible to complete on the last class. Yeah, I have uploaded for morning 7:30 batch. Please cross check and confirm. There is one folder called as machine learning. Inside the machine learning, there is another folder called as regression. In that, everything is available. Okay, that is 7:30 a.m. batch. Now I'm just uploading in the next batch. Yeah, guys, just to give me 2 minutes. I'm not seeing your questions. Don't ask, please. Wait for 2 minutes. First, let me complete uploading. Yeah, Girija, you have to contact the admin regarding that. That is not in my hand. What are the question you are asking now? That is not in my hand. You have to contact the admin. You have to connect to the admin. Girija, and explain the same thing to them. Surely they will help you. Yeah, 7:30 a.m. It is clear now. Now, please confirm by 6 p.m. batch for you. There is machine learning folder. Inside the machine learning folder, there is again regression. Each and every one of you, please ask what, you can clarify all your doubts. If few of the students are having the doubts, please stay back and ask all your doubts. Then only please leave. I am uploading for now 7:30 p.m. batch also. Just wait for another 2 minutes. I want the confirmation from Anwar Ali. Train test split notes, bias variance trade-off notes, everything was uploaded for you. 6 p.m. batch. Please check and confirm. Now finally 7:30 p.m. batch. There is a folder called as machine learning. Yeah. Sir, in the folder of 7:30 a.m. batch, the bias variance notes is fully loaded. Okay. Some theory part is missing, which you have shown in the PPT is as is. What I have written in the notepad, it will be different. My running notes now. Right? Just to give me a minute. First, let me upload this one, same for the 7:30, and later I'll discuss with you. Yeah. Anwar Ali, could you check the notes once and please confirm me? Yeah. Available? 7:30 p.m. batch. Yeah, Neeraj, can you tell me which part is missing? Neeraj, except notepad, everything is same, right? So you want me to upload the notepad also? Just give me a minute. I'm trying to upload the notepad even. Yes. Right? Please check once, everyone. Everything is uploaded. Yeah, Vamsi. PPTs. Every PPT is available. First, introduction to regression, followed by linear regression, ridge regression, lasso regression, non-linear regression and regularization. All the regression techniques are available. Theory only now. We have completed theory only, right? Vamsi Krishna. Everything is there. Sharma, could you check? Could you check your drive also right now? I'll wait. Yeah, others, if not, if you're not having any questions, you can leave. Who are having the subject related questions, please stay back and ask what are the questions you are having. Except notepad file, everything was uploaded. As I've told you now, notepad is standing notes. Other than notepad, everything was uploaded. Can you share the screen of bias variance table comparison? Which table? I didn't understand your question. You're asking this diagram. Sharma, is this is what? One minute. Okay, 1 minute. Not this one, right? Hmm? Yes. Done? Okay. Yeah, please make a note. Done. If no questions, can we continue tomorrow? To fix only a overfitting problem, not underfitting problem. Only overfitting problem. Mayur. For underfitting, other examples are, I mean, other techniques are there. Only purely for overfitting. Roshan, sir, could you reply to my question? Roshan, I missed your question somewhere. Sir, for sequential data splitting is 80 and 20 is done, right? For this data, only time series model can be used. Yes, exactly. Time series model. Yeah, Sharma. Sharma, that is 1 minus lambda into ridge, lambda into lasso. It is not 1 minus lambda. That is the reason I have modified, right? First, I have told that wrong one, and later I have told this shown and I have explained, right? And clearly, I have written lambda means percentage of lasso. That first one is wrong. Yeah, for underfitting, Leela. Yes, for underfitting, we are going to explain later. But answer is very simple. Underfitting means data is not sufficient. The solution is add the more data. That is the only solution for underfitting. For underfitting, data is not sufficient. Right? Roshan, we are going to discuss still logistic regression, KNN, nav-based, SVM, that is support vector missions, decision tree, random forest, bagging technique, boosting technique, like this, so many are there. In the sequential order, we are going to get them. Roshan. Sharma, 0.1 means 10% lasso. Yes, zero point 0.1. 0.1 means what are the lambda value you are considering, that is lasso. 0.1 means 10% lasso, automatical 90% reach. Leela, there are no algorithms like region lasso means no, there are no algorithms. For underfitting, solution is only adding the data. No, no algorithms. Done.